All right, so we're just talking through question 1.2 here. And the question says, the table below summarizes a survey of the number of pets per household in a particular town. Okay. It's, personally, I wouldn't have let the moderation go through a little bit because it should have been a number of pets as a percentage. Okay, that's where it can get confusing. Okay, if you're reading too quickly, okay, one could forget that is percentage households. So in this whole town, 80% of the homes have no pets, 33% have one, 36 have two, 13% have three or more. Okay, if you misread that as numbers, it's a completely different question. Then we get into hypergeometric territory because we know the number, okay, in the survey. So this is for the whole town. That's important to note. We're working with percentage, not number of households. Okay, and in terms of identifying whether I'm going to use binomial or hypergeometric, okay, if you don't know how big the sample space is, okay, we don't know how many, that says we don't know how many households there are, then it can't be hypergeometric. For hypergeometric, you have to know the size of the sample space. Okay, so first question, what's the probability, okay, that X is bigger than equal to 2? Okay, that there are more than 2 pets per household. Well, that's simply 36% plus 13% is 49%. So that's for the whole town, guys. Okay, so the probability, okay, that a random house has more than 2 pets, okay, is 49%. Okay. Now the next question says, okay, a random sample of 10 households is selected from this town. Okay. Determine the probability that the sample will contain more than 8 households with at least 2 pets. Okay. So what we're working with, X is the number of households with more than 2 pets. And we know from a sample of 10, what's the probability that more than 8 homes, okay, will have more than 2 pets. Okay. So the trick is this binomial hypergeometric? That's the most difficult thing. Well, first of all, either a home has more than 2 pets or it doesn't. There's nothing in between. So there's 2 options. Okay, right? It's going to be binomial. But why it's binomial is really the easiest thing to spot is because you're working with the whole town. So the sample is really large and we don't know the size of the sample. Okay. And if we take a household out from a whole town, it doesn't affect the next draw of a household. Okay, so you're not changing the probability. So for me, independence is a key thing. Once you've done one thing, once you've taken out one household, will it change the probability? Well, it won't, okay, because the sample size is too big. Okay, so they're independent. Independent for me is a key thing, okay, about whether to use binomial or hypergeometric. So it's a binomial distribution. If you're taking 10 households out, the probability that a random household has more than or equal to 2 pets is 0.49. So NP is 10, 0.49. We're going to be using this formula over here. So to work out the probability that there are more than 8 households from the 10, okay, well, more than 8 is 9 or 10. So the probability of 9 households is going to be from 10, choose 9, 0.49 to the 9, 0.51 to the 1. Okay, and the other option is X is equal to 10, from 10, choose 10. Okay, one thing you need to save a bit of time. 10C10 or 10C0 is always 1. Anything to the power of 0 to 1. So in your calculator here, you actually have to put that in. 0.49 to the 10, and you get an answer of 0.0091. Remember that the front of the sheet said that you have to give all answers to 4 decimal places in a stats paper. And we also hello to the AP students. Thanks. Right, off you go. Okay, no, I just made it into a video. Right, okay. So now, okay, that is the end of question 1.2. Okay, that was question B. Right. Now for question C. Okay. So question C, there's a new random sample of n households is selected from this town. Okay. So we don't know the size of the sample. Okay. Looking for n. Okay. The probability this new sample contains at least 1 household with more than 2 pets. So again, it's about reading carefully. Okay, the previous was more than or equal to 2. This is more than 2 pets. Okay, so more than 2 is 3 upwards. So Y is equal to the number of households with 3 or more pets. And if you look at the previous page, the number with 3 or more was 13%. Okay, so from the table, in this particular sample, where we're looking at more than 3, the probability of that happening for any random household is 0.13. Okay. Now they want to know what's the probability, okay, that in a random select, we don't know how many big the sample is, but we want the probability, okay, that the question says the probability this new sample contains at least one household with more than two pets must be bigger than 70%. So we want, if I let y be equal to the number of households with 3 or more pets, we want to know the probability that y is bigger than equal to 1 is bigger than equal to 70%. Now I can't work out the probability that y is equal to bigger than equal to 1, okay, because there's too many. Well, I could go 1, 2, but that's too much of a mission. Okay, and also we don't know what n is. Okay, so we have to use the logic, okay, that either there's one or more households, okay, with 3 or more pets, or there's no house. That's a complementary space of that. So probability of y is bigger than equal to 1 is 1 minus the probability that y is equal to 0. Okay, and so we get negative probability y is equal to 0 is bigger than equal to negative 0.3. If I divide by a negative, so we're going to go solve this equation over here. We're going to solve the probability that y is equal to 0 must be less than or equal to 0.3. Okay, so y is a normal distribution. Okay, the probability that a household has more than 3 pets is 0.13. We are looking for the size of the sample. Okay. So I've got to work out the probability that y is equal to 0. It's binomial distribution again. Okay, so the probability that y is equal to 0, okay, is NC0. I'm just using your normal formula. P is 0.13 to the 0, 0.87 to the n minus 0. Okay, you need to know this, guys. NC0, okay, the number of ways of choosing nothing, so that's 1. And anything to the power of 0 is 1. So 1 times 1 disappears, and you're left with 0.87n. So the probability y is equal to 0 is 0.87n. So in other words, combining those two things, okay, probability of y is equal to 0 is 0.87n. 0.87n must be less than or equal to 0.3. Okay, so that's what I'm trying to solve now for n. Now let's just think about things, okay, because in the end we want to know it must be less than or equal to. Okay, so remember what you've really got here. Okay, this is probability. Okay, you've got the function. Okay, probability is 0.87n. Okay, and we want the probability. Now, a graph of y is equal to something which is if you had a to the x, and a lies between 0 and 1, that will always be a decreasing function. So the graph of if I put n against p is equal to 0.87n will be a decreasing function. So we want to know what must be the values of n so that the probability, which is on the y-axis, is less than equal to 0.3. Okay, so what I'm going to do is I'm going to find out, first of all, what goes with the y value of 0.3. In other words, I'm going to solve the equation 0.87n is equal to 0.3. And if we use logs, in other words, n is equal to log 0.3 base 0.87. And we get n is equal to 8.64. So this point over here, okay, is 8.64, 0.3. Okay, so we want to know the probability, how big a sample must we have so that we guaranteed that this probability over here, okay, works out to be less than 0.3. So to be guaranteed that the probability is less than 0.3, I have to have a sample of either 9 or more, okay, in order to be 70% probable that that situation happens over here. So your solution is n must be bigger than equal to 9, because then the probability will be less than 0.3, which is what we want. All right. Okay, hope that makes sense. Thanks.